Cool. Good morning, everybody. This is the May 11th CAPN office hours. As always, this is recorded and posted to YouTube after. The link will get posted into the agenda doc as well, and I'll drop it into our Slack channel. Just make sure everybody has access to go view that. So don't say anything you wouldn't want to be posted to the rest of the world. And yeah, we'll get started. I think we're going to skip over PSAs because Lee, I know you have to drop after a half an hour, and I want to make sure that we have enough time to talk with Clayton and David. So if you want to get started on that. Also, if anybody wants to, because this is a bunch of new folks, give introductions to who you are to the group. That would be good.
I can go. I'm a current grad student at RIT, interested in CAPN project. Nice to meet you all.
Jason, Clayton, David, anybody want to give a quick introduction to who you are?
Sure.
Hey, I'm okay, Jason.
Well, that's Clayton. No, I'm just kidding. I will introduce myself. I'm Jason. I work at Red Hat and have been working with Clayton and David on the KCP project, which I imagine we'll talk about a little bit.
Prototype.
Yep, you got me.
So easy to say.
A quarter in the job.
I'm Clayton Coleman, so I've been working on the Kubernetes project for a very long time, and kind of pushing things along, you know, with like evil mastermind kind of plots in the background for like how can we all get more value out of the ecosystem, and how can open source evolve to support, you know, users' needs is kind of the thing. And so this is just the latest in a series of kicks I give to the Red Hatters among us, and trying to make people's lives easier.
Awesome. David, would you like to do an intro? Otherwise, we can get started. Cool. All right. So basically, thanks, Clayton, for coming in here and chatting with us over Twitter about this. I think there's gonna be some good overlap here, especially from the last call. It sounds like there's a lot of similar goals that we're trying to attack from a multi-cluster as well as a multi-tenancy perspective within Kubernetes from what we're doing. To give a little background, I don't know if you all are well up on what virtual cluster is, but it originally started from the folks at Alibaba, and basically started in the multi-tenancy repo within Kubernetes SIGs as a way to nest Kubernetes within Kubernetes as pod-based control planes, and being able to take that and then sync workloads from those multi-tenant or from those single tenant control planes into a large scheduling domain in essence. So it uses some parts of, it doesn't, at the lowest level, it doesn't use all of Kubernetes. It basically treats those top level clusters as a way to shard out into those lower level deployment, or into those lower level superclusters. And that sounds very similar to some of the things that you all are approaching with the syncing logic that you've built into KCP and so on.
Yeah, and a lot of so KCP is kind of like a prototype. It was, you know, we've known for a long time that single cluster tenancy in Kube has challenges, and you know, one of the things that I was kind of, and you know, even since the very early days of like federation in Kube, there was this, you know, how do we take the benefits within a cluster, which is a single failure domain, and either lift them up or spread them out or put cut lines. And so I'd almost say there's like a bit of parallel track for most of the last 7 years, which is like, how do you cut Kube up? And we have, there's lots of good ways to do it. And actually the best part is the core primitives are okay, but we have some fault lines that don't quite cut, or like, you know, you make different trade-offs at different levels. And so yeah, KCP from a prototype perspective was, could we go one step further than virtual cluster? And there was another dimension, which is, could we take the cluster out of the equation? And part of this is like, so I don't know how much folks deal with this in their day jobs or their personal experiences. One of the things that I see a lot of is people have multiple clusters, and most people at a large enough enterprisey scale or whatever, they absolutely have the problem of like, how do I keep a workload running even if I bork one of the clusters? And so today, most people have some layer on top, which is like, take it and move it, like in GitOps and CI, CD, bash scripting, whatever. And then, there's the various projects in Cube which do it. And I was like, okay, can we come back to that and say, is there a way to go one step further? So KCP is really a mix of those ideas, like a cluster tenancy. And then could we go a step further and say, could we all agree or find a way to get everybody who has this problem to be like, wouldn't it be awesome if most people creating Cube apps never had to know about the cluster they were on? There have been other projects like Virtual Kubelet and Fargate stuff and EKS and all these things that kind of map to those ideas. So I was really looking at different perspectives. So yeah, I do think there's a fair amount of benefit if we could figure out how to do the use cases match and do the solutions match. That was kind of maybe like what talking about today could be really useful, is like, what are the problems and what are the solutions and do they overlap or not?
Very cool. Yeah, I agree. I 100% agree. Lee, do you wanted to bring up anything specific? I know you had some ideas on where you were thinking that the VC integration or where we could match up.
Right. So when we originally working on virtual clusters, so I think also Fee also mentioned this before. We are heavily focused on the hard multi-tenancy model in Kubernetes, and obviously the straightforward way is that we provide isolated control plane to users, and then we use Syncer to actually sync their workload and resources, which are concerns on the runtime to the underlying runtime cluster. So that is the originally goal. But we're recently also looking at a new scenario where actually you can think of that, okay, you can provide a generic hard multi-tenancy model to the whole cluster tenants. Everybody will have a small virtual cluster to interact with. So this is a generic model, which is exactly what we are doing today. So I'm also thinking, actually thinking another scenario where, for most of the users, they actually do not need to have a virtual cluster. They just talk with the underlying runtime cluster. But for certain workloads, especially for CRD-based workloads, then we can create a small virtual cluster for them. It's more like we kind of package the virtual cluster as part of the workload in that case, which will give them some certain isolation level for CRD-based workloads. But for the other, maybe majority of the users, they don't need to actually package this API server, which I'm thinking maybe KCP can be integrated into that approach. So we basically package KCP for the users as a virtual cluster, but we do the same thing to make the workload running in the runtime cluster. And in that case, the virtual cluster assigned to that tenant just need to only care about the CRD-based workloads in that case, as well as other resources needed. So this is a new scenario I'm thinking about, which kind of different from the generic multi-tenancy model we are heavily focused on before. But I haven't deeply think about whether it's best scenario for KCP to work with existing virtual cluster. So it's just a rough idea in my mind.
Yeah, and I think one of the questions that and this is probably a longer term thing, but I wouldn't want, so the logical cluster idea would be, I think it's most valuable if most people deal with it most of the time. So then the question would be, in a single cluster today, everybody has the same versions of the API, so controllers have an easier time. Except that's not actually true, because nodes are controllers and nodes actually have different views of what they're capable of, right? So as you're going through upgrading machines, a node is implicitly determined by what it can offer. And so there's an angle here for, we never really in Cube tackled the problem of, if you go layer 15 different extensions onto a node, so which everybody roughly does, right? Whether it's storage or networking or policy or security or monitoring tools or security tools, we don't really have, it's handled basically as it's up to the user or up to the admin. One of the thoughts I had would be the inverse of that model is applications evolve at different rates. A big pain point if you upgrade a single cluster is upgrading all of the APIs at the same time. We're not really pushing any of the work to the controllers, right? Because the mechanism in a controller could very easily look at 2 or 3 different versions of a resource, right? That's as people write integrations and extensions, it's actually reasonably easy to put some of that load on the controller. We just don't do it today. So one of the thoughts that kind of informed this would be, in the long run, if you've got a lot of integrations and your integrations don't deal with version skew and drift and aren't upgraded in lockstep, you run into some challenges. And so logical clusters actually, to me, might be something that I think belong in Kubernetes in the long run, or something like it, where you might actually say which versions of the objects you support. And it's up to the people, the other controllers in the cluster to deal with the implications of it. We really, in Kube today, we've never dealt with a breaking core API, nor do we really have plans to do that. We have some machinery that does an okay job of it, but every new events v2 actually has or the events evolution has been kind of painful. We've had a couple of other examples, CRDs, and still are painful. And so I was kind of looking at what's the machinery I would use to break the lifecycle connection between a cluster and an end user application. That to me is what logical clusters and CRD tenancy is one dimension of it. So there's kind of an angle of not everybody wants to make that trade-off. Cluster is still a pretty useful boundary, but we're actually not. The more stuff you pack into a cluster, the more challenges you have operationally as life cycles diverge. So the thought would be a new tool in the toolbox could be used in many different ways. That's the logical clusters idea, separate from KCP, the prototype, which has other concepts in it. So logical clusters might actually be something that down the road, we start off at a higher level, but then come and could actually benefit people doing schema evolution or workload evolution on a single cluster. I don't know if that trade-off is worth it, but I also think Kube is a single Kube cluster probably does too much today, and there's no real boundary between user plane and data plane, or control plane and data plane. So another part would be maybe all the APIs in Kube. This was another idea, was maybe everybody who goes to a Kube cluster should only talk to a logical cluster that has a very specific set of APIs in it. And that could be the default for all Kubes. The root, the unmodified, the normal Kube behavior would still be there, but is there a way that we could all kind of come up with a slight iteration of Kube that still feels exactly like Kube, but cuts a couple of those hard boundaries? That's another thought for where logical clusters might go. So I don't know if those ideas resonate. These are pretty far out, but I wanted to kind of, everybody who's doing some level of hard tenancy, if we could have more tools that let us do hard tenancy, trying to find out what tools can we take and modify and make more useful, because the cost of some of the tools is high. You can't really use the admission chain effectively today in lots of little clusters, but the admission chain building into the admission chain of Kube is where webhooks are kind of a failure mode of admission. Admission's much more powerful than what webhooks can do. I had been hoping to move to a world where we can move more logic down into admission, but it's not going to work. It will require changes to how we do tenancy and multi-cluster as well. So those are kind of the ideas that sit around that.
I think I agree with most of Clay's the statements, because when I look at the KCP project, so to me, I'm more interested on that, the virtual, what do you say that, virtual cluster or
logical clusters. I deliberately did not try to confuse people with virtual clusters, but we need better vocabulary for
I think that idea makes me more exciting about multi-tenancy, because if you think about a multi-tenancy, about how to separate the control plane. So I think even with KCP, even with our current VC model, Chris knows we are trying to make virtual cluster as a arbitrary type. And there's no fixed type. It can be any type of virtual cluster. That's our goal. That's the reason we have KPN, right? We have designed the interface. We just designed the API. We never, fix a implementation like it has to be vanilla Kubernetes. So to me, KCP fits to VC model. There's no big challenge because we already support Sync CRD already. So it's all about, we just limit some of building, minimum set of building objects, and the rest of the objects make it at CRD. So I think the current VC Syncer and everything probably will just, with minimum modification, we can support that. So I like more idea about the logical cluster idea, because that seems to be, just think about it, it's just give a minimal set of capability to the user. It's not a full set of capability, which can limit, because more easy to use, more secure, more less error prone, because you don't have that fancy API. Nobody can just call it, right? You just focus the API that you are caring about. So I like that idea more. And especially the logic cluster, I think it should be lightweighted, right? If I look at the repo, it seems you put etcd as a process. So you just make it one binary, including everything, right? It's not that you have kind of like not a complicated, microservice-like type of architecture. It's just simple binary. And make it as simple. That's another benefit of it. So I see KCP, I'm more interested in that regard. It's like a simplified interface to give a minimum set of API that only people care about, and probably a lightweight resource saving. I don't know if this is really your goal, Clay. You can just crack me if you're wrong. If you really try to save resource, but I don't see that as a major modification. I see the first part is a major motivation. So yeah, that's my point. So I don't think the multi-tenancy part there's a lot of challenges. It's just you have a Syncer, right? Everybody just trying to put the kind of thing to a root cluster. The Syncer logic we have a honestly, I already see about 2 to 3 versions of Syncer which may all work already. So it's not a big challenge. So I think if this two project wants to collaboration or whatever, you can. Chris and I can think of how to make KCP as another type of virtual cluster in our term. So just another type of virtual cluster. So just follow.
You can actually keep the word logical cluster. For example, you can provision several logical clusters in that case.
Just is our VC in our term. Exactly the same thing. You can say just put a logical cluster in VC. So everybody get a logical cluster. The rest of the thing is just the same, because the Syncer part of as you may know or not, so we are trying to make it as a framework. It's not exactly tied to a particular implementation or even API type. So we try to make it as a framework to just support all kind of Kubernetes supported object synchronization. Maybe next we can try to make it as some extension point, make people easy to extend, like plug in something like that, right? When you do synchronization, you try to modify the object due to mutation, make it easy. Like maybe that's another way that Chris and I can think of how to move the KPM project further.
And a key point that you brought up, and I think this is one, is like the set of APIs that are visible inside a cluster defines what you can do. And today there's just one, which is everything. If you do virtual, you can do minimal. What I'm looking for, and I think it's kind of like, I think the mindsets there is there's different sets of APIs. It should be easier to get different sets of APIs. Everything we can do to make chunks of APIs feel more put together. So like sometimes, like, a key example for me, in tenancy, having a set of implicit RBAC rules that you can't change, right? So like today in Cube, you can do that, but there's always the risk that someone cuts through the lines. A defense in depth approach makes sense. Running multiple Cube API servers makes sense. Then it gets down to like, how efficient is that and all that. And I'll be honest, like for some of the things we've been thinking about for a KCP-like evolution would be, we'd like to run little app clusters as a service. And we'd actually like to get into the billions range, sharded, of course, but like that kind of scale, be like, okay, well, where's the fat come from? And it comes from, 99% of people don't change the default Cube definitions, but everybody gets a copy of those resources. CRDs don't change, but they're basically the same. How would you offer APIs, let someone extend it, but then not override it? So like, imagine, an end user has a version of a pod that actually is malicious or breaks through some security rules. trying to avoid trying to solve that problem is, or let me frame it a different way. I want to open the door for going and solving some of these problems in different ways. So like there's when we were thinking about KCP and we were talking about this in the community meeting, like imagine Cube API server as a library. You can pick and choose what APIs you want is one problem. You can reuse it or go and cut off some of the abstractions that you don't like, but it still looks like Cube and feels like Cube. Valuable for a lot of people in the ecosystem. It's valuable even for Cube to some degree. It's just, there's not a use case demanding it today. So it'd be like bringing the use cases together so we have that library. Once you have kind of a library mentality, then there's like, well, what are the other features? So one of them is like logical clusters. One of them is how do we support watches more scalably, client tooling and all that. That would be kind of where we were thinking about starting with. And then we can kind of play around with the ideas and say like, if we had this library, we were all converging and we wanted to cut APIs out, what would that look like? Would we actually have like virtual cluster as a project could, provision these or whatever, making it easier for people to have forks of chunks of code, I think gets at the heart of what I'm trying to enable no matter what.
Yeah, you know what? When I first look at a KCP, I thought it's just the major refactoring of the Kubernetes API server. Because that's something that I think we should do, but nobody did that. But I have to, because for simplicity, we have to leverage whatever just out of the box. We have to use, no matter how complicated it is, we have to, because we have to do API server. Although we claim it's cheap because it's. But in fact, it's not very cheap. It's still a very big, complicated chunk of thing. But most people just doesn't need those many things.
And like this is another angle that I don't think we've explored enough, but I hear a lot is the definition of conformance in Cube was very specifically chosen to be about workloads. But what happens is it's just nobody really cares. CNCF, the Linux Foundation requires vendors do it to get certified. But I mean, like as a project, what we actually want is if you do an app in one spot, it should work in another spot. And then we should have variations on it. And to be fair, very little of like conformance should be about like boring features in Cube that like one person uses. Like that's cool, but I don't think it's really the point. What we would really, and this is again, my personal opinion, I go to SIG, the conformance working group, almost every week. I skip sometimes, and it's my fault, but that mindset would be, if you can do something conformant, the underpinning of it should really be up to you. We never wanted Cube to be a monoculture in library or in implementation. It's just in practice, it kind of is. So there's an element here too of like, if we can get the library side of the project going, get the use cases and get people who are motivated, there's not really a lot of resistance. I was trying to kind of build some of that consensus because API machinery is ultimately going to have to do a lot of it. And so when I thought, and talking to Dan Smith and others, like we were kind of like, okay, well, if we could get enough people motivated and get some cut lines agreed and some use cases agreed. The problem has always been we didn't have enough use cases to really argue through what a KEP would look like. But I kind of think just based on even what I've heard in the last couple of weeks, I think we probably do. We should just see if we could get like a bunch of them sketched out over the next couple of months and be like, here's a KEP that factors the API server. And I bet you we could probably get really close in a first pass. Like it's not even that hard.
Okay. Yeah, I think to me, I think the real challenge is the use case, because that is biggest motivation, right? So I don't know. So yeah. So based on my personal experience, so I think Lei may have more experience. When we talk about the interface that we expose to user, the use case is always the primary concern. Otherwise, we have a big resistance of doing anything. So I thought I bet this project also may face the same problem, because the problem is, although we have so many problems, but we already has a Kubernetes API server that's up and running. So how do you convince people that switch to a simpler version, because it still works with a bad heavy version, right? So I think we need to clearly define some use cases for that. So yeah, because just my personal opinion, because when I first look at your description, you are talking about putting the pods into the controller, right? That's one of the putting the pod in the CRD and move pods into the controller, right? That's the KCP claim, right? So
the thing is,
yeah.
Sorry, excuse me. I mean, the thing is that in KCP today, also based on the demo that has been done in KubeCon, there are obviously several layers that are, gathered together. You spoke about the logical cluster part, which is much more on the Kubernetes side of things, hacked Kubernetes fork. And then there is the Syncer or cluster manager, which is mainly, an example of what it could be. Precisely, even on the cluster customer source, it's just example domain. So obviously, those various type of things are bundled together in KCP for now, because to just at least to showcase what it can do and what the purpose could be. But obviously, there are different things that possibly should land in different places, or even some of them in sub projects. So yeah, I think we have to bear that in mind and not take KCP as a monolithic thing. It's mainly just the minimal API server and resource tenancy, not to say CRD, because it's mainly resource tenancy, resource type tenancy. Sorry, and that's to me more the core of it. And then the cluster manager on Syncer are mainly just examples of things that you can build upon that according to the use case you have.
Yeah.
And probably in the future, even on the KCP documentation and repository, it would be much more, explained as long, while other use cases are being explored and maybe other demos or other examples are being added.
Yeah,
be more clear.
I think that makes more sense. When I look at the KCP more and more, I kind of I get more ideas. But when I first glance at it, if you claim that, okay, we are trying to get rid of pods and make it under controllers, I was thinking KCP was not fitting a Kubernetes scenario. You are just leveraging Kubernetes to try to solve other, non-Kubernetes framework problems. So that's my first impression. But now get more and more, I try to understand, because this is not your intention. So.
Well, and like another example of something, so like an idea would be, one of the things is like transparent multi-cluster. So like, could you take a Kube app and literally move it across 2 clusters without anyone being the wiser? Thinking through that, like that's a thought experiment. That's a hard problem. Various projects have tried that. We want to learn from them and see if we can move the needle. But a feature that might come out of that, and this is where like the no pods might come in, is from a scaling perspective, from a separation perspective, letting people create pods is problematic. But if we could let you see the pods, but not actually have them at the higher level, do most people most of the time do anything except delete pods? And do you actually need to represent them? That's like a building block, like logical clusters is a building block, stripped down Kube API server might be a building block. Another one might be something that's halfway between an API service and a CRD that lets you blur the lines, so that when you say, I want to go get pod logs, instead of it having to hit the thing and have a pod object, we could actually just proxy through. Some of those may not be as useful for like some of the tenancy use cases, but in others, it would have let you set it up so that you couldn't actually physically change the API, but you could see them. So like an example would be, you go into a logical cluster and you can do get foo. No matter what you do, you can't actually change it, so that you can set up those rules. Like you might have APIs that come from other places, APIs that come from real clusters, or you can mix and match. So like maybe you have a CRD with a sub resource that's implemented somewhere else. These are more like building block kind of ideas, but yeah, it's we brought a bunch of ideas together, and now we're kind of teasing it hard into something that other people might find useful.
This would somehow leverage also on the CRD work that already has been done, but probably making it even more generic, because for now CRDs are quite limited, and even in Kubernetes, issues, there are a number of requests for being able to add additional, sub resources, for example. Other people already had those type of problems. So being able to declaratively, represents new resources, and then define the behavior. Either it would be stored in the KCP layer or proxied to underlying clusters, for example, would be something that would obviously be beneficial more generally in the Kubernetes ecosystem.
Interesting. Yeah, the syncing mirroring objects back that you can't change is an interesting thing that I think we've dealt with in some regards, with just very simple backporting of things back through, but it really ends up being that you still end up having two versions of the object that we're then maintaining, which it sounds like you're kind of approaching it slightly different, where you're actually trying to make it so that it's the physical objects. You just can't do any of the creates, updates, and you can only do the reads.
And Federation, Federation had this challenge as well, like the V1 Federation. And then it's tough because like you can't do list watch on it. Like you can't get the controller watch. Another idea, and this was like, if we could, like, we need to figure out a way to bulk watches together. It's kind of a general cube problem for a lot of controllers. Like it's really ugly to build a bunch of caches, and the client side, it works, but it's not obvious. One of the thoughts would be like, if we could make getting a bunch of watches to start at the same time more efficient. There's like 3 dimensions of it: watching multiple resources, watching chunks of resources, like 3 different namespaces at the same time, or watching 3 different clusters with different criteria, but having something that kind of pulled those together. Again, nothing like, there's no prototype code for any of this, but it was kind of that, could you help people build controllers that didn't have to care about certain resources? People are using aggregated APIs more. Are there ways for us to reduce the cost of aggregated APIs, or have some of these mixed scenarios? Those are ones that, like, use case wise, everybody's got a bunch of pretty different use cases. That one's a little harder to see, could they all overlap? But I think it's worth trying, just because like the use case for KCP that we were trying to like, okay, let's try to make this use case work: transparent multi-cluster, create a deployment, sync the deployment to the clusters, don't pull replica sets or pods back. Could you show that? So that was kind of like how we had been thinking about coming up with a use case and seeing what the technology would have to look like. Doesn't mean that we would actually get to it or it'd be something to be implemented, but it's kind of like thinking through that spot.
Yeah, since Clay mentioned that, so I actually had a question because so how is KCP different from the aggregated API server? Because aggregated API server, you probably can still do a lot of customization of the API that you want to show, right?
It's funny because like in OpenShift, we use aggregated APIs heavily, and I use them for 2 things: virtual APIs. So like the pod metrics API is kind of a virtual API. It's translating from a different domain. We also use it to front real resources. So like we have a virtual resource shim projects instead of in front of namespaces. So you can create, delete projects. But if you only have RBAC access to projects, you can't change namespace. Okay. That was like it's good, but it's actually still pretty hard to do it. So like there's maybe a second goal of API server, which would be aggregated APIs are still just a little too darn painful to run operationally at scale, just like webhooks are. One thought would be, if you wanted to do an aggregated API and have it on the same lifecycle, or you wanted to do some of these like tricks, could you mesh them more cleanly with existing? So like, could you take a CRD and combine it with an aggregated API for all the bits that aren't CRD based? And the answer is yes. Could you make all the client tools properly handle it generically? There's still bugs in like, people just assume like, I was actually looking at the Smithy documentation the other day for AWS's IDL. And there's a concept that we've been missing in Kube, which is like this object. This object is actually just a representation of this object from OpenAPI, but it's something like the Smithy IDL actually had. And I was like, oh, that's a thing that we would hit if you made it easier to do some virtual resources through aggregated APIs. So it's not that, I think aggregated APIs are a part of this. It was more like, what are the tools, like come up with a use case that kind of we think is aspirational, where we'd like to get better at for hard tenancy and CRD tenancy, work through the common tools and problems in Kube and see if we can get anybody else interested in any of those, and then be like, hey, let's work together. So like a logical cluster could be one. The discussions we're talking about here about like library of Kube, like Kube API server is a library, so you could slim stuff down for virtual and still be conformant. Like that's other stuff that like I want to get conformance to the spot where you could run the conformance tests and be like, yeah, this is a conformant cube cluster. It's using a stripped down version of the library. And then we're just like, we only really, like, you shouldn't have to jump through some of these like legal process hoops to really be able to use cube effectively. So I guess like, and I don't know, like I didn't want to monopolize the whole meeting. We'll probably just keep continuing to poke at some of these examples. It sounds like for vCluster, maybe we want to do a follow-up and chat about some of the places where, like, we're going to try and work on getting logical clusters described out a little bit more effectively. Maybe we can spend some time, come back and then say like, here's like 3 ways that virtual clusters and logical cluster could actually benefit from each other based on other feedback we're getting from other people, as well as then the separate topic would be for minimal cube API server. What are the virtual, like what in virtual cluster, what are the use cases folks have today for changing how cube API server works as an interface or as a library? And we'll just try to get all those written down as use cases and help centralize them. Does that make sense?
Sounds great. Yeah, love that idea.
And who should I poke the most, I guess?
Probably Faye and myself would be.
Yeah.
I think you're muted.
You're muted.
Getting too good at pressing that mute button. What I can try to do is set up a follow-up. I'll probably try to set up a follow-up time where maybe we can just walk through some things, maybe on Slack or whatever, or chat through it. And then we can just like talk about, you know, if you guys have a specific cut line or use case, or you can point me to some of those existing docs, I can go do some investigation on it and come back. David and Jason are kind of like splitting up, like pursuing people and collecting stuff right now. So like, there's definitely an angle here. I can definitely work with y'all on this topic specifically, and Jason and David can support me as necessary.
Sweet, that sounds fantastic. Yeah, we'd really appreciate that. The conformance side of things is going to be really interesting, especially because we're implementing ourselves as a CAPI implementation, but as of right now, we actually don't pass conformance, which is kind of against their spec because of simple things that are like, if I recall correctly, Faye or Chow or Charles, like correct me if I'm wrong, but it's like we can't support subdomaining in the service namespaces or the pod namespaces, for example, because of the cluster domain that gets specified at the tenant control plane could be different from the super clusters, for example. It's like really things like that are like, do we really need this? So.
Well, and that's actually a great example of if you want to do multi-cluster stuff, eventually you need some of that stuff spec'd out and a little bit less restrictive because there are going to be limitations. I bet you there's other people who have those limitations. And so it's like, we don't want conformance to be a chokehold. We want it to be actually very useful at, like, we want conformance to basically work to make multiple cube projects interoperate. And if it's not accomplishing that, like that's feedback that, you know, we can handle in the SIG Arch and the conformance group as well. Because I think we'll hit other use cases like that as well.
Yeah, I think this cube project does is kind of help each other in the sense that, you know, the VCs, we focus more about, you know, single object, but I think KSP is helping. It's focusing more on making the VC or logical cluster more efficient, or, you know, more customized, you know, fit customized needs kind of thing. Because yeah, this is the most part I like, this kind of collaboration. I think next part maybe one thing I can do is I can try to connect some of our internal use case of VC. I can understand what are the APIs they use, because they're coming from the production team. I don't know exactly which API they use. I can collect some information and share you guys. Maybe Chris can share your internal, you know, experience about how you guys supposed to use the capability of the virtual cluster. You just need CRD, or you need a bunch of building API that heavily. This kind of thing maybe help Clayton to, you know, polish your use case.
Yep.
Yeah, sorry. And maybe one point is that we are currently working, and that should reflect quite soon in the documentation as well, at least in the development documentation, working on, you know, separating those layers so that you can just run KCP, the minimal API server, without anything, without the cluster manager nor the syncer, or only with the cluster manager, but then start your own syncer that would, just have, from and to kube configs, and then implement stuff. So that would make it much easier for everyone to leverage on what exists already in the KCP, repository, but then be able to change only one part of it, or just use only the minimal API server with logical clusters and CRD tenancy if you want, if you don't need the rest. So we are in the process of allowing this way of using the various components.
And David, actually, that's a really good point. So it would be really useful, David, for you to study what virtual cluster is doing with its syncer. And so maybe that's actually an angle, which is we probably need to categorize and look for commonalities among the existing syncer impls and try to get like a taxonomy going. That would be great, actually, because I think that helps other folks who have syncer-like problems. And ideally, that may be something that is, again, like a carved out piece, which is the broad effort of sync. What libraries, shared tools do we all have? Which implementations can we bring together? And how do we make those implementations more efficient is definitely something has been very much on our mind.
Yeah, because I was wondering, hearing what we discussed just before, in cluster API, so I assume you have some, CRDs to represent the cluster or stuff like that. I looked into it some time ago, but I don't remember. So, and as I said, for now, our own cluster manager is just, based on on an example CRD that is mainly just a kube config. So it's really, minimal. And so it could be very interesting trying to hook into, into KCP attempts of other projects at defining, cluster customer sources and also syncing mechanism. Maybe we could also try, to experiment this and try to see what we can bring from other projects like virtual cluster into, a very minimal KCP.
Yeah, definitely the syncer code and the cluster controller code that is in the KCP repo is probably the least mature code that does syncing or cluster management in existence. So I don't think we want it to grow up and become the mature one. I don't think we want there to be one, right? Like I think you bring your own and it should work against KCP. File bugs when it doesn't. The cluster controllers for other cluster types, for other deployment types, for whatever, should work against KCP file bugs if it doesn't. I definitely don't want there to be only one syncer in existence. And if there is, I don't want it to be ours, because ours is the worst one.
Yeah, because in any way, it's our plan to multiply the number of use cases or example that makes sense to work with KCP. So I think this would be one very interesting, seeing the common parts between cluster API and KCP syncing and how we could manage those.
I totally agree. I think so. In my opinion, the syncer is the least valuable part in KCP, because this is there's nothing new from here. It's just a bunch of engineering work, and we have already best practice. So I would like to really, so if you want to use syncer, if you think our syncer can fit your requirement or you need some changes, just bring up issues. We can try to resolve all of them. So I try to minimum the work in your side for the syncer side, but you can put all your efforts on the other cool concepts other than the syncer part. So that's my hope, because so Chris and I know actually making our syncer support KCP should be minimum. I mean, with minimum changes.
Yeah. I think the reason we started with our own syncer was we wanted something we knew would work against KCP. But that isn't the intention. If we delete it all, that's fine. All right. We want something that's good and more mature and better. At least that's what I think. I don't know.
I think there's just a topic of syncer coordination, collaboration in the ecosystem, and that what are all the ones that are out there? Let's make sure that we have a good description of the problems. Like maybe that we've either fold this into a new investigation or a sub bit of the transparent multi-cluster, because transparent multi-cluster kind of depends on syncing and some flexibility. So, so it sounds like that's another good one. Are there any other topics y'all would like us to take back? Any other areas?
As of right now, I can't think of any. I think like the way that you structure your cluster controller and how you actually address like what are clusters, I think will be really interesting, because I know we're currently tackling that with two different types. We have like our original, which was virtual cluster, and then we have the new, which is CAPI, which has its own types. And there's going to be a lot of the types of those implementations, like how that actually integrates together, like thinking about maybe what Knative's done with duck typing, and like if there's ways that we can make this more fluid between all of those types, I think could be really interesting.
Yeah, and that actually on the tenancy side, like one thing would be if we can inject, like, so part of like the mental mindset on tenancy is like, I have a set of APIs I inject. I don't necessarily want to inject the same APIs. So like, and this is like kind of what we do with virtual resources and aggregated API servers in a few places today, is like there's the fundamental one that's an admin one, and then there's an end user one that is restricted scope. Looking at what the different facets of a cluster are. So a big thing for me would be like, I've been trying to find out who in the ecosystem has the best transparent multi-cluster pattern that we can potentially and like bring everybody around. So like Karmada has one, KubeFed 1 and 2, 3, 5, 7 have all done variations on of it. I know that y'all have a couple of different bits of it. Is like, can we get everybody together and be like, okay, look, if this is what we agree on and it's mostly transparent, what does that look like for the physical resource, the logical one that a human might see that's more scheduling? What are the different scheduling options? And maybe there isn't just one. I actually probably think there probably would be multiple, but could we find some, you know, what is the representation that makes sense if you don't care? And what's the representation that makes sense if you do care? And do we have tools that can make that surfacing easier? Because that's the big thing for logical clusters for me, is you might have one resource in one namespace that only admins can see, or a set of admins can see for physical clusters. Everybody else gets a very slim, minimal one that is, you know, maybe not even tell you what the name of the cluster is. Maybe it's a mapping that tells you like something that's relevant to you. Like, this is your location A. You don't care what location A is. If an admin comes along and remaps you to location A, you still don't know. Like, it's a detail under the covers, and just trying to think through what that would look like. That's a deeper dive on the transparent multi-cluster one, but we can come back to that. And that would actually be really useful, yeah, with clusters. Okay,
Definitely.
and then are there any other like areas of the project that you guys have that you think we don't know about? Because I think we definitely, everybody kind of glosses over everybody else's projects, and there's so much that nobody can read everything. Is there an area that we should chase?
I would say the only thing that we haven't talked about, which you kind of called out a little bit in the way that you've changed things, is like what we're doing with how we interface with nodes, and how we basically proxy everything through as like we proxy through virtual nodes to your tenant control plane, and can address them via a proxy, which we do some rewriting of namespaces. I don't think we haven't talked about that as well. Basically, to do tenancy within the clusters, you still create, unlike say for instance like a V cluster from the Loft folks, where everything gets from one virtual cluster goes into a single namespace. We actually renamespace everything and prefix it.
Yeah,
and so
we want to do that as well. And Jason and I were talking about that. Like, could we come up with a standardization of that pattern that we could say, like, if you've got this problem, you use it, and then everybody just picks the same convention? Would be excellent. Yeah,
would be nice.
Yeah.
That would be
Keep us involved in that, please, because that will directly reflect a lot, or directly change a lot of what we're doing, and it is a big problem to solve, because like that's the main reason why we have to have the way that we do our the actual node connections, because we run a really transparent proxy that just looks up the namespace that you're supposed to proxy it through, and then rewrites the request so that it goes to the kubelet direct at that. So I think there's some interesting things there.
The biggest challenge at this replace is the namespace length has a limitation, which is too short.
Yeah, that's actually a really good point. And okay, so this is definitely so we kind of have like the 3 layers of depth. I think, you know, of all the projects, y'all are basically, what I could probably frame this as is, how can we help you be more successful, and where are the places where any of the goals we have that don't quite align, why don't they align? What's the difference in the mindset? Teasing that apart, that'll actually help us. We can take that on our side and focus on it. So it sounds like we have a lot of stuff to go do.
Yeah.
And I'll.
So indeed, I think KCP covered a lot of areas. To me, each area, to me, multi-cluster is a big thing, because I see so many requirements, and in my opinion, there's no single solution that can fit everybody. I'm pretty sure about that. I think it has to be, case by case, but at least we can summarize the usage pattern and give best practice. That'd be very valuable for many of the users.
Yeah, I agree.
And just to add this as a note, if y'all haven't had this on your plans to talk with, I would reach out to the law folks as well and kind of get theirs, because it is interesting. I mean, it's a different use case, or it has similar use cases, but a little bit different. And they just open sourced V cluster itself. Like 2 weeks ago or something like that.
Yeah, I think I saw it, but I didn't dive deep enough to know all the differences. So that'll help going back and taking a look through it a second time. So thank you.
And then I guess the last question I would have is, what's the long-term plan? So this is a little bit specific to a couple of us that are from the Apple side of things. What's the long-term plans on like repos and ownership? I know if we were to ever try to help out in any of these places, I'm going to get a bunch of pushback, and I'm curious if the long-term plans are to try to bring this into a Kubernetes lens, or I guess I should say a Kubernetes org, at least from a GitHub perspective, because I know myself and Wei and James are going to basically not be able to contribute or help out in much deep ways unless it's under the Kubernetes lens, which is, it's organizational things. So
yeah, I don't. So the thing that, and this is like, I was kind of talking to a couple of folks like within the community, and like one of the challenges we have is we're trying to avoid generating too much churn on the core projects so like, I would say this is like, can we build consensus with folks from within the orgs? I don't think the intent right now is for KCP. Like, you think of it as like prototype, it'd be, there's probably the mental mindset that everything in there either ends up as a Kubernetes cap. It may have a life as those evolve, so like as a feature branch. And so what we probably need, we haven't quite sorted out all the details, but we didn't want to go to project stage without figuring out what we're actually doing first. So that's probably the biggest wrinkle. I'd probably say, yeah, like KEPs and finding alignment on that's easy. Feature branch on Kube is easy. That'll probably stay as it is. And then the other aspects that don't fit, whether it's Kube or a CNCF or something else, I don't know yet. And honestly, I'd probably wait to see what does come out of it, because most of it is like what are the things that we cobble from things like even Karmata or others that aren't quite CNCF or Kube. Like, I don't want to be just Kube projects, but I understand there'll be some challenges for some organizations for sure.
CNCF is a little bit more okay, but it's still a process for us. So, but at the end of the day, I think the idea there is just however we can help out. I want to make sure we can get as close as we possibly can, because it's really interesting what y'all are doing.
Yeah, and I mean, multi-cluster is homed under SIG API machinery and all that. So it's more what I don't want is to, if we get people wanting to cross domains, I don't want to. OpenStack had this challenge for a while. Sorry, I was a dump truck going by. OpenStack had this challenge for a while, which is the only way that you could get anything done in OpenStack was to go create it as a new OpenStack project, at which point everybody like cut your project apart until it was just the smallest sliver of an idea. One of the things we were looking for is like, if there's something that's not quite Kube, but it's Kube adjacent and Kube is a library, what does that change things? The home for it should definitely be something that's amenable for contribution. So we'll take that into account for sure. Cool.
Cool. We really appreciate you jumping on here for the last hour and chatting with us about all of this. This is really cool.
Nope. We appreciate your time, and it helps us actually it helps us orient to where y'all are hitting limitations and where we can help, and then potentially like look for common things. So we really appreciate it.
Yeah, definitely.
Fantastic.
All right,
y'all. Well, I think we have 4 minutes left. If anybody, I don't know if we have enough time to jump into any of our other topics, but we can push those to next week if that makes sense for Faye, Charles, Wei, everybody.
For the KPI, we can just sync up on the Slack channel. So for the new things that we need to work, but small. I don't think we have anything need to discuss right now.
Yeah, I think the biggest thing that I wanted to do is just do a little backlog grooming and try to get some more issues filed for what we're doing next. Just moving on to how do we integrate the two? How do we actually make it so the CapN works with VC? And so we could, we'll just file those issues off or async, and then we can collaborate over Slack.
Yes.
Sound good? Cool. All right. I'm glad we were able to do this. I'm going to call it and stop the recording, and then see y'all on Slack.
Bye-bye.
Bye.